I will explain you moment area method, deflection of beams. Deflection of beams is there. In that deflection of beams, one topic is there, that is moment area method, and this method is very useful to find deflection. Any type of deflection we can find. Means any type of beam will be there, we can find the deflection from moment area method. This is the best method in deflection of beams, and you can approach so many difficult questions from moment area method in a easiest manner. Okay students, so we'll start from here. This is our cantilever beam. Cantilever beam is there and total span is L, and W is the point load acting at the free end of the cantilever beam. Clear? This is cantilever beam which is fixed at one end and free at the other end. So for moment area method, first you have to learn how to draw the bending moment diagram. Bending moment diagram should be must. You have to draw bending moment diagram. Clear? So point load is acting at the free end, and this is the bending moment diagram for this beam. These bending moment diagrams I will explain you in the SFD and BMD topic. Clear? So this is our bending moment diagram, cantilever beam, point load acting at the free end. So this is our bending moment diagram. Clear? So one scientist were there, that is Morse. Okay, so we will write here Morse theorem. Morse theorem will be there, and with the help of Morse theorem we can find the slope and deflection of this beam, and that will be the moment area method. Okay, so I will write the theorem here. Theorem is origin minus reference is equals to 1 by EI area of bending moment diagram. Clear? This is the Morse theorem, and this theorem is for slope. Okay, so we have to write the equation, first equation for slope only. Okay, so this theorem is for slope. So origin minus reference is equals to 1 by EI area of bending moment diagram. Clear? And what is the origin and what is the reference? Reference is the point of, this is the point of zero slope. Okay, reference, we all know that what is reference. Reference is something zero. Okay, so this is the define for slope. So reference is the point where slope is 0. Okay, and origin is the point where we have to find the slope. Clear? Reference is the point of 0 slope, and origin is the point where we have to find our slope, where we have to determine slope. Okay students, so this is our Morse theorem, and you know Morse circle was their topic, that Morse. So this is the god in strength of materials, and so many subjects were there. So this equation we have to apply. Origin minus reference is equals to 1 by EI area of bending moment diagram. Okay, so what is origin? Where we have to find the slope, and what is reference? That is slope should be 0 there. Okay, so this is cantilever beam. This is cantilever beam, and what is the boundary conditions of cantilever beam? We all know about boundary conditions. See, this is our cantilever beam. This is our cantilever beam, and point load is acting here. So this is our elastic or deflection curve. Okay, this is our elastic or deflection curve. So here deflection, this B point and this A point, here deflection is YB is equals to Y maximum, and for slope we have to draw tangent from here, and the slope is also here at B point, this will be also here maximum. Okay, so in cantilever beam at free end, what is the condition? At free end deflection should be maximum, and slope should be also maximum. Clear? And at A point, that is fixed end, this is fixed end, A point, here see, here no deflection is there, so here deflection is 0, and slope is also here 0. Okay students, because if we will draw the tangent from here, so it doesn't make any angle like that. Okay, so here slope and deflection both are 0 at A point, and slope and deflection both are maximum at B point. This is the cantilever boundary conditions. Clear? And this curve is known as deflection curve or elastic curve, this curve. Okay, so we will apply here. So we have to find the point where slope is 0. So where slope is 0, at A or B? See here, at A slope is 0, and we have to find maximum. We have to find maximum slope here. So maximum slope will be at B. Okay, so B point is our origin and A point is our reference. So what will be the equation? This equation is for slope, defined for slope. So theta B minus of theta A is equals to 1 by EI. And what will be the area? Area should be between A and B. A and B, between A and B, we have to write the area. So theta B minus theta A. Theta B is the point of maximum slope, that is origin. One subject is there in mechanical engineering, that is operation research. So you have to remember easily operation research. From that subject you can remember Moore's theorem easily. Okay students. So origin minus reference. Origin is the point where we have to find the slope. Reference is the point where slope is 0. Clear? So slope is 0 at A point and maximum slope is at B point where we have to find the slope. So origin is theta B and reference is theta A is equals to 1 by EI. Area of bending moment diagram between A and B. Clear? So theta B minus theta A. Theta B is our maximum slope and theta A is our 0 is equals to 1 by EI. Area. What will be the area of this bending moment diagram between A and B? This is the triangle, half into base into height. This height is WL. Okay. And L is the length. So what will be the area? Area is in negative, half into base is L into height is WL. Okay students. So maximum slope, from here we will get maximum slope, that will be WL square divided by 2EI. This is our maximum slope. Got it? Did you understand the Moore's theorem, students? Moore's theorem, did you understand the Moore's theorem concept? So this equation is defined for slope and this is the equation, this is the Moore's theorem, and we have applied here and determined the maximum slope for this cantilever beam. Clear? So maximum slope will be WL square by 2EI. Clear? Now again we will be going to find the deflection. Okay, what will be the deflection? Maximum deflection. So maximum deflection also will be at B point. Clear students? So now we are going to find the deflection. See here. Same equation will be repeated for deflection. Okay, you have to write the equation for slope. Same equation will be repeated for deflection. So we will write same equation. What was the equation our? Theta B minus theta A. Okay, origin minus reference. Same equation will be repeated for deflection. YB minus YA is equals to. Don't apply origin and reference in deflection. Okay. Write the equation for slope. Same equation will be repeated here for deflection. YB minus YA is equals to 1 by EI. That is moment of area. Moment of area of bending moment diagram between A and B. Clear? YB minus YA is equals to 1 by EI, moment of area of bending moment diagram between A and B. So YB minus YA is equals to 1 by EI, that will be AX bar. This is our theorem. So YB is Y maximum and that is 0 is equals to 1 by EI. What will be the area? Area will be half into base into height minus 1 by 2 L into WL. Okay, and multiply by what is X bar? This X bar is the very important term and lot of confusion is there so many students have lot of confusion in x bar, and they always used to did the wrong concept. They have applied wrong concept in these. Okay, so listen, what is x bar? This is the centroid of the bending moment diagram. Clear? This is the centroid of the bending moment diagram. This one is centroid of the triangle lies at from base it should be at distance of 1/3, and from vertex it should be a distance of 2/3. Clear? Where the centroid lies at triangle centroid. Clear? Triangle centroid, from base it should be at 1/3 and from vertex it should be at 2/3. Okay? So this is 2/3 L and this is 1/3 L. Total is L, total span is L. So this is 1/3 L, this is 2/3 L. This is the centroid of the triangle. Where we have to take this distance? This distance should be taken from the point where slope is non-zero. X bar is the distance measured from the point of non-zero slope, and this point is having non-zero slope. Got it? X bar is the distance that should be measured from the point of non-zero slope. So where the slope is non-zero? The slope is non-zero at B point. So x bar should be measured from B point, and from up to where? There, at that place where the centroid of the triangle lies. So centroid of the triangle is at 2/3 L. Okay, got it? So x bar is the distance measured from the point of non-zero slope to the centroid of the bending moment diagram. Clear? So what will be the x bar? 2/3 L. Okay, so y max is equals to minus WL square by 2 cancel. So what will be the minus WL cube by WL cube divided by 3EI. This is our deflection. Got it? So this is a very simple example, because first we have to cover the basic approach. Our basic should be very strong, then we will move further on. Okay students, so this is the basic approach. Then what is the moment area method, how to deal with the Morse theorem, how to apply the Morse theorem, what is the basic idea about moment area method, that I have covered in this topic. Got it? Okay students.